All right, so let's go back. Let's look at, let's see, we got a couple things that we've kind of started in module 4. We talked about circles, and been an assignment up for a while about circles, but I know people are still working on that. And even if you finished it, I think it wouldn't be a bad idea to maybe, it's been a while, been 20 days, so let's maybe go back and review that a little bit, and then we'll see how far we get today. We might just get into introduce. How many people are done with 4.1?
I don't even know.
You may not even know. Yeah, I mean, I know there are people that are, but and then the other thing is, and I'm not sure how far we'll get with this today. If whatever we don't finish today, we'll just hit tomorrow. Is reviewing parabolas, standard form equation of a parabola. And it's similar to the circle stuff, but let's kind of, it's been a while. Let's talk about this stuff a little bit. So let's start off with maybe the circle stuff. If I've got a circle, let's kind of remind ourselves how we talk about this stuff. What are the parameters? What are the numbers or the quantities that make that circle unique and define it? And just think about it in terms of the circle. I mean, how could you specify a circle? What would you need to pin down if I wanted to specify a circle? I need to know where it is, for one thing. I've got to know where the center is, right? So what are the parameters that we assign to the x and y coordinates of the center? Remember? H and K, yeah. So the center, we'll just call it C, has coordinates H and K. So those are two numbers that we have to specify, right? And then what else? That tells us where it's located. What else might we want to know about the circle? Say it again. The radius, yeah. We want to know the radius, don't we? So how big is it? R. Okay, so those are the parameters. Now there's an infinite number of points contained in that circle, right? And all of those points have to be represented by the variables x and y, right? And so we want to come up with then some equation that involves the variables x and y and the parameters h and k and r. Do you remember what that looks like? What's our standard form equation of a circle? What's it look like? See if we can put on the blanks. What goes where? What goes in here? X.
And H or K.
X minus H squared plus y minus K squared equals R squared, right? That's it. All we've got to do here is, well, that's our standard form equation. We can do lots of things with that, right? So let's look at a couple examples. Like, what about this? What if they're telling us, for example, we've got this circle with a center at this point, and it contains some other point with coordinates -6, -4. And my goal is to write this in standard form. So we want to get it into that form, right? So let's just take a picture of that. We want to be able to fill in the blanks. Okay, so how are we going to do that? Are there parts we can plug in right now? Okay, well, you're right, we could do x and y. Our goal is to be able to just plug in numbers for the red parameters, right? If they had given me what the radius was, I'd be done. I could just plug that stuff in and be done, right? So how far could we get towards the answer right now? What are probably the first things we might want to plug in? 4 and 1, because those are values of h and k, aren't they, right? So they're telling us the center, so that's h, and that's k. We got 2 of the 3 numbers that we need to be done with the problem. So far we can write it like this. X minus 4 squared plus minus 1 squared equals r squared. Right? I've got to know what r squared is. How can I figure out what r squared is? There's an idea over here. Brian had an idea, I think. Yeah, we know that here's a value of x and y that has to work. This is a point that's on the circle, so it's a value of x and y that has to satisfy the equation. It has to work in the equation. That's what the equation is for, right? Is for defining all the values of x and y of all the infinite points on the circle that are going to work. Okay, so we could do that. We could plug in this x value and that y value. So negative 6 goes in for x, negative 4 goes in for y. And then when I do that, what's the only unknown going to be in this whole equation? Yeah, r, or r squared, right? I'm putting in numbers for x. I've already got numbers in for h and k. So I should be able to just simplify the numbers on the left, and whatever I end up with is equal to r squared. Right? Does that make sense? Okay, so if we do that, what do we get? Negative 6 minus 4 squared plus negative 4 minus 1 squared equals r squared. And yeah, I mean, I guess it'd be nice to know what the radius is, but if I'm just writing this in standard form, all I really need to be able to do is plug in a number for r squared, right? So I don't even really have to know what r is if I'm just going to do this problem as it's stated up here. I just need to be able to plug in a number for r squared. Well, that's the number I'm going to get. Let's see what it is. So what's negative 6 minus 4? Squared. 100. Good. So this becomes 100. What's negative 4 minus 1? Squared. 25. So that's what r squared equals then. So, well, what is that? 125. All I've got to do is plug that in right there, and I'm done. Right? So my answer would just look like x minus 4 squared plus y minus 1 squared equals 125. That's it. That's in standard form, right? Okay, now what if, I've got another example here, but we won't even do that example. We'll just, how about instead if we just, oh, where'd it go? Thought I had one. Oh, never mind. For that one, that's all we can do. Does that make sense? Okay. All right. All we're doing is trying to algebraically find out what the values of h and k and r are for this circle, and we're given 2 of them, so I had to find the third. Okay. The other thing we might want to do is something like this. What if they give us the equation of a circle, but it's not in standard form? We want to turn that into standard form. So we want it to look like that, right? We want it to look like x minus h squared plus y minus k squared equals r squared. So this guy right here. What am I going to have to do to get it into that form? What do you think? That's my goal. I want it to look like that. Is there anything I could do to make this thing simpler from the beginning? What could I do?
Subtract the 100.
I could subtract the 104. Yeah, I could do that. Good. And then I'm going to have to maybe get the x terms and the y terms together. What about, before I even start doing that stuff, is there anything about those numbers up there that I could, what could I do? How, what do you mean by that? Divide by 2. Yeah, good. I could notice all of the coefficients are even, right? So I could divide, that's one thing that might be a real good idea. I could divide both sides through by 2. And what do I get? What's that first term gonna be? X squared plus y squared minus 12x, keep going, plus 10y plus, it's half one of 4, 52. Equals, and then 0 divided by anything is just 0, right? That makes sense? Okay, so then now we can start talking about how do we get from, that makes things a little simpler, how do we get from here to here? Well, Ryan was on the right track. We want to get the number on the other side, but what about the other stuff? What do we call something like that, where I have x minus some number squared? Right, we've talked about that as being a perfect square, right? Because it's a factor times itself, so it's a perfect square, right? So we've got to rewrite it in that form, don't we? Right, so what's that going to look like? Let's take all the x terms. If I want my x terms to look like that, what do? Right? This is just that process that we went through in last module, module 3 of completing the square. So let's take my x's. What do I want to do there? You're right. We're going to go through that whole process, but I have to leave space for a number there, don't I? Right? Because I'm going to take these first two x terms, and my goal is I want to turn those into a perfect square by adding just the right number to those two terms. Right? So we're going to leave a space there. Plus, let's do the same thing for the y's. I've got these y terms, so I've got the y terms y squared plus 10y. Leave a space. Equals, and then we'll push that 52 over to the other side to get rid of it. So we just get a negative 52 on that side. And so our goal is to turn the x's into something like that, the y's into something like that, right? Perfect squares. And then on the other side, whatever number we're left with is just going to be r squared. Okay, so what's going to be, we can do this much, right, before we even start thinking about it. Okay, so what are we going to get here for that number?
-6.
How'd you get -6? That's right.
You divide the -12 in half.
Good. So whatever the coefficient of x is, so there's my -12. I'm just going to, that's b, right? We'll take half of b. That's the number that gets combined with x. And so what's h? We already know what h is. What's h if we compare this to our standard form? It's, what is it?
-6.
It's 6, isn't it? It's because whatever number is being subtracted from x is h, right? So x minus h becomes x minus 6, so h is 6. That's one thing we know already, right? The x coordinate of the center of the circle is going to be at 6. Okay, but how do we get that? Remember, to get that, we really had, there's one other step we can't skip. We had to add a number to these x squared minus 12x, those two terms, to make that happen. What's that number?
36.
36, yeah, whatever this number is squared, I've got to add to both sides because it's an equation, right? Does that make sense? So I got to add the blue number, 36, to both sides. And that's how we get this x minus 6. That's good. What about the y's? Austin, what's the number we have to add to y down here? 5. Good. Half of 10 is 5. But in order to get that, what red number do I have to add to both sides? 25. So what's the value of k? -5. Yeah, because what's, y minus what number is y plus 5? Well, y minus -5. Remember how that we have that little trick? The value of k is going to be it's going to be the opposite of whatever that operation is. That's going to be the sine of k, -5. And then what goes here? Well, now we just add up the numbers and see. -52 plus 36. So 36 and 25 add up to, what, 61? So what's -52 and +61 added together? 9, yeah,
Wait, what?
That's a negative.
Oh.
right, cause that's a
Sorry.
negative and that's a positive.
Okay.
I heard it up there, right? Does that make sense? So then now that's, for this problem, we're done. We wrote it in standard form, but what if they had asked something like this? Where's the center of the circle and what's the radius of the circle? Instead of doing a whole new problem, let's just go back to this last one and answer those questions. So the center is at what point? What's h? 6, good. And what's k? -5, good. And the radius is what? That's r squared is 9, right? So what's r? 3, yeah. Yeah, just gotta take the square root of that, right? The radius is 3. Make sense? Okay, and so if we wanted to do one, like select a graph. So what if we had, let's see if this works. Oh, there it is. So what about a problem like this one then? How would let's just talk about how we could do this. We don't even have to do the whole thing. How could I do this problem? If they're giving me this equation, let me make this a little bigger. If they're giving me this equation up here, how could I know what circle is graphed by that? What would I have to maybe do to that equation? What are the things I need to know to identify the graph of a circle? Got to know the center point and the radius. Well, I can't see the center and the radius in that equation very easily. What should I do to that equation? By break it down, what do you mean?
Put it in standard.
Put it in standard form, right? I just have to convert this into standard form by completing the square for x and for y, right? And then once I do that, then I'll be able to say, okay, now they're standard form, so h is this number, k is this number. Those give me the coordinates of the center. And then whatever number I get on the other side, if I square root it, that's r, right? Just like we did last time. And so I can use that information to go down through my choices and see which one's the right one. Okay, does that make sense? Okay, be honest with me here. Is that for the first day back, is that enough? Okay, so maybe the thing to do is let's just take this in, rather than pile on the parabola stuff today, let's just go with that. If you're done with this assignment, why don't you go back and just do like a problem or two, just make sure you know you could do this now. You did it 3 weeks ago, but can you do it now? And then if you're fine with 4.1, then go on and work on 4.2 a little bit. That's fine. And if you might have some questions on that, bring them on up if you do. I'll give you today to kind of catch your breath and get back up to speed on this stuff.